The Fire Information for Resource Management System, FIRMS, distributes near real-time active fire data within 3 hours of satellite observations from the Moderate Resolution Imaging Spectroradiometer MODIS aboard the Aqua and Terra satellites, and the Visible Infrared Imaging Radiometer Suite, VIRS, aboard Suomi NPP and NOAA 20. FIRMS fire maps, both global and US-Canada, provide data in an interactive visual format where users can explore a variety of satellite fire data over different periods of time from different instruments in multiple locations worldwide. Discover and learn how to use NASA's FIRMS tools and features. Use this tour to explore layers, data and features, and view fires and imagery for today and historic fires. FIRMS has 2 modes, Basic and Advanced. Basic mode is initiated by default when you access the fire map for the first time. It provides new users with quick access to the active fire data, most viewed dynamic imagery and overlays for today and the last 24 hours. Although it may appear that the whole world is on fire, this is simply due to the relative density and symbol size of the data at this scale. When you zoom in, you can see that there is a lot of space between many individual hotspots. If zoomed in too much, it appears that the entire pixel is an active fire. However, the hotspot could be anywhere in the pixel. In this image, you can see that the fire looks like it crosses this road, but the fire may only be on one side of the road. If looking at VIRS data, the fire could be anywhere in the 375 meter squared pixel. If looking at MODIS data, there could be only one hotspot anywhere in that 1 kilometer squared piece of land that makes up the pixel. Or there could be multiple fires in the 1 kilometer squared pixel. It doesn't mean that the whole pixel is burning. Advanced mode provides users with more features, including satellite orbit tracks and overpass times, as well as a variety of overlays to give more context to the satellite observations. In both modes, users can search data by time frame. 24 hours is the default setting when you first open FIRMS map. It shows fires from 0 o'clock Greenwich Mean Time yesterday to present. Click on the information icon below the 7-day circle to see the date and time indicated range for the display of active fire detection data. Change the selection to Today to view the active fire incidents. Selecting 7 days will enable the Historical tab. This option allows people to view the last 7 days of active fire data. When selecting 7 days, the pick list under the Historical tab jumps to week, and 1 week of data is displayed. However, the range of days can be adjusted by using the pick list under the Historical tab. Use the pick list under Historical tab to select the range of data to display from the past 1 to 31 days. At the bottom of the map, there are other tools, which include the Timeline tool. The Timeline tool is the default when viewing the Historical tab of data, but will need to be selected at the bottom of the screen if you are in the Current tab. This will bring you back to the Historical tab. Your selected dates will appear along the timeline along the bottom of the map. As an alternative, users can adjust the selected timeline, changing the number of days or weeks up to 31 days. On the right of the timeline, as opposed to using the pick list tools under the Historical tab in the right toolbar. Users can access information about individual active fires or hotspots. If you are looking for hotspots for today, the past 24 hours, or up to 31 days ago, make sure that you are sufficiently zoomed in to the area on the map where the fire is located. Click on an active fire or hotspot to display the attribute information collected by each sensor, MODIS and VIRS, on each satellite, Terra, Aqua, Suomi NPP, and NOAA 20. Information includes coordinates, brightness, acquisition time, fire radiative power, confidence, and whether it was collected using day or night bands. Additionally, the time can be adjusted to Greenwich Mean Time or to your local time. As you move your cursor around the map, the coordinates appear in the thin transparent box at the top of the map. Additionally, the selected time frame is also indicated to the right in the box. This type of data is often referred to as temporal extent in remote sensing. To see the time since a fire was detected, open the Fire's Hotspot menu item on the right and select time-based. The color scale varies from deep red, indicating a fire was detected less than 6 hours ago. Bright red indicates that the fire was detected between 6 and 12 hours. Orange, 12 to 24 hours. And yellow indicating a fire was detected over 24 hours ago. Overlays in basic mode consist of administrative boundaries like roads, cities, and countries. There are two options available, basic and detailed. The basic overlay includes major roads and geographic boundaries, while the detailed overlay includes major roads, geographic boundaries, geographic features, and cities. In advanced mode, there are more options, which will be covered later. I'm going to skip over covering advanced overlays and move on to dynamic imagery and static backgrounds. In the Dynamic Imagery expansion menu, you can view satellite imagery for the currently selected day. In basic mode, only options for corrected reflectance true color imagery for MODIS or VIIRS will appear. In advanced mode, there will be options for more satellite imagery, including images from GOES, Landsat, Sentinel, and false color images for VIIRS and MODIS. At the bottom of the map, a gray slider marker will appear when you select a dynamic imagery dataset. This slider reflects the day of the data that is displayed within your selected timeline, indicated by the blue translucent box that appears over the selected dates. For example, if I choose a week as my range of data, then the dates for that week will be within the blue translucent box, and the gray slider will be on the day of the dynamic imagery that is displayed over the map. The range of dates of data that is selected can also be changed by dragging the blue translucent box on the timeline, or by sliding the ends of the box to encase different beginning or end dates. The gray slider can also be dragged to different dates, which will change the dynamic imagery to the newly selected date. Toggle VIIRS or MODIS corrected reflectance imagery, true color imagery, on or off by clicking on the layer you want to view. This is useful to see clouds and smoke at the time of the satellite overpass, which may prevent the ability to detect fire activity in those areas. It is worth noting that MODIS and VIIRS sensors are on multiple satellite platforms that each provide observations at different times of the day. Also, if today is selected, then there is a chance that only some imagery will show up. This is because the satellite has only passed over the locations with imagery present on that day. By selecting 24 hours or using the timeline, you can look at previous day's imagery. View the orbit tracks to show what time the satellite will pass over an area by selecting the satellite of interest in day, ascending, or night, descending in the orbit tracks and overpass times dropdown. Here you can see orbit tracks of the satellite Landsat 8. Match the swath view from Landsat 8 data included in the HLS product. In basic mode, static backgrounds can be changed. The blue marble is the default background. However, there are both street maps, which display roads, cities, and geographic markers and features, which become more detailed as we zoom in, and there are also topographic maps, which can be better seen as you zoom out. This option can be selected as well. In advanced mode, there are also other background options that can be applied. There is a light gray that you can see here, and dark gray. These can be applied to showcase the chosen datasets more predominantly. At the bottom of the screen are other tools, including pan, measure, location, layers, timeline, share, screenshot, and help. We've already covered the timeline in detail previously, so I'll focus on the other tools listed here. The pan tool allows you to move around the map. The measure tools can be used to measure features on the map, including measuring areas in acres, hectares, square kilometers, or square miles. To measure area, click at different vertices of the shape of the area you are measuring. Do not forget to close the shape. Once you click on the starting point or double-click your endpoint, the shape will close and the total area will be calculated and appear. Distance can also be measured in either kilometers or miles. To measure distance, click on the starting point and then double-click on the endpoint. The measurement will appear in your list along with other measurements. You can also measure multiple adjacent lines by single-clicking each line until you reach your endpoint where you double-click. You can also measure multiple independent lines. The individual measurements will appear in the list under the Measure tool. The distance measuring tool can be useful for measuring the distance between fires or populated areas, as well as measuring how far smoke may be traveling. Both the area and distance tools can be used to track changes to impacted areas over time and take measurements of burned areas. The location tool allows users to find, select, save, and zoom to locations of interest using coordinates or a place name. Users can save multiple locations, which enables firms' users to quickly access areas of interest to their research or areas of active incidents. For example, structures, cities, or other geographic areas can be marked and the fire data can be looked at in the context of the area of concern. For different land managers or fire incident managers, there may be more information needed about administrative boundaries, active incidents, and historic ones. For this purpose, Firms Global offers Advanced Mode, which includes additional overlays of data, more information about data collected by individual sensors on specific satellites, gridded fire hotspots by sensor, and information about burned areas. The Advanced Mode has additional overlays than Basic. Beyond the coastlines, borders, and roads available in Basic Mode, there are also latitude and longitude lines, aerosol index from Suomi NPP's Ozone Mapping Profiler suite, human built-up and settlement extent, as well as protected areas that can be activated as overlays. The latitude and longitude lines overlay displays the latitude and longitude lines and labels over the map. The Ozone Mapping Profiler suite, OMPS, aerosol index from Suomi NPP displays the aerosol index for the selected date. OMPS aerosol index is used for looking at smoke concentrations. It helps track where smoke is going. To understand how this works, I'm going to use an example of a historic fire. The August complex fire in California that started on August 16th and wasn't considered contained until November. I'm changing the timeline to show 31 days of hotspot data ranging from August 16th to September 15th, 2020. We will change the gray slider to show the aerosol index overlay on September 7th. There are two separate but related overlays that display aerosol index information. The OMPS aerosol index range is smaller, limited to 0 to 5. The OMPS aerosol index pyrocumulonimbus extends by a factor of 10, reaching to 50, which allows users to view pyrocumulonimbus events. A pyrocumulonimbus event is a fire-caused or fire-enhanced thunderstorm that in its most extreme form pumps high amounts of smoke and other biomass-burning emissions or aerosols into the lower stratosphere. Since aerosols can remain suspended in the atmosphere and be carried in prevailing high-altitude wind streams, they can travel great distances away from their source, impacting air quality in areas far from the source of the fire. As you can see in this example from the August complex fire on September 7th, aerosols from the fire reached high into the stratosphere. If the pyrocumulonimbus data is on, you can see where the aerosols reached this altitude. If you turn it off, you can see the altitude of the aerosols that weren't considered pyrocumulonimbus, and you can see how far the aerosols traveled. We could use the Measure tool to measure this distance. Another measurement people may want to understand is the distance from an active incident to a populated area. The human built-up and settlement extent from Landsat allows firms' users to view at a 30-meter resolution areas where people have developed the land into an urban landscape. This is important for individuals and incident managers to understand the potential impacts from fire proximity to people nearby as well as far away during pyrocumulonimbus events. While the human built-up and settlement extent allows users to see where people are living or have developed the land, the Protected Areas overlay provides boundaries of protected areas from the World Database on Protected Areas. Here is the area of Yellowstone National Park, and if you click on the area, the information pops up. Clicking elsewhere will display other areas information. Just across the border from Yellowstone National Park, there is the Tetons Wilderness to the south. The European Regional Protected Area layer provides the same type of information as the Protected Areas overlay, but specifically for European countries. The information comes from the same source, the World Database on Protected Areas, but because there are so many protected areas in Europe, this section is kept separate to keep FIRM's performance efficient. If FIRM's users are specifically interested in European protected areas, then this overlay can be activated or deactivated if it is not of interest to one's research. In both Europe and around the globe, these boundaries can inform users where current fire activity is encroaching on adjacent areas with potentially different management practices. On the right navigation menu, the Burned Areas expansion menu expands to show months of the year that can be selected. Burned area data will appear for any year selected. The colors correspond to the approximate month in which the fires took place, or satellite measurements detected large-scale, 500 square meters, reflectance changes for the year selected. If the year selected for the burn area is not the same as the year selected at the top or in the timeline, then a warning will be issued in yellow stating select year doesn't match the timeline year. The hotspot active fires on the map will not be from the same year as the burn areas. If users want to view 1 month of burned area and active fires at the same time, they can by selecting 1 month of burned area and 1 month of active fire for the same month. Another option for identifying burn areas is using the layers from the Dynamic Imagery expansion menu. False color images can be layered on MODIS corrected reflectance 721 or VIIRS corrected reflectance. These false color images from MODIS and VIIRS make burn areas easier to identify, appearing in different shades of red against the vegetated areas that appear bright green. This is the August complex on November 21st, 2020. The red area is the area that burned as seen here in the Terra MODIS false color image. If I change the date to August 5th, 2020, before the August complex fire started, we can see that this area is bright green, indicating that it is vegetated. And if I jump forward in time to March 16th, 2022, we can see that some of the burn area is recovering and becoming more and more vegetated. MODIS and VIIRS provide this data at 250 meter resolution. More detailed 30-meter resolution data is available as adjusted reflectance, harmonized Landsat and Sentinel-2 HLS imagery. The HLS project provides consistent surface reflectance data from the Operational Land Imager, OLI, aboard the joint NASA-USGS Landsat 8 satellite and the multispectral instrument, MSI, aboard Europe's Copernicus Sentinel-2A and Sentinel-2B satellites. However, because Landsat and Sentinel satellites, which carry the sensors that provide the data for the HLS product, do not have full global coverage daily, the images will appear as swaths for areas that did have a satellite overpass on the day selected. The combined measurements from Landsat and Sentinel enable global observations of the land every 2 to 3 days at 30-meter spatial resolution. If there is no HLS data on the day selected, try searching within 2 to 3 days of your currently selected date. It is also worth noting that HLS data is available on a 2 to 4 day lag time, so HLS data will not be available for today or the past 48 hours. HLS true color imagery is always available if there has been data collected by Landsat or Sentinel, but false color images from HLS are not available unless sufficiently zoomed in. Hotspot active fire locations coupled with burn area data from MODIS, VIIRS, or HLS can be used to see the movement of the fire front over a period of time or be used to identify areas that have recently burned, and therefore may pose less risk as fire fuels in those areas may have been reduced by previous fires. Whether researchers are studying previous fires or assessing risks of active fire incidents, FIRMS has many effective tools available, providing FIRMS users an opportunity to use current and historic satellite data about fires to help incident managers, researchers, and scientists understand more about wildfires worldwide.